Hello students, today we are going to talk about the Rutherford scattering experiment. But before I start this lecture, make sure to like and subscribe to our channel. The Rutherford scattering experiment was conducted by Ernest Rutherford and his students Hans Geiger and Ernest Marsden in 1909. It provided critical insights into the structure of the atom and led to the development of the nuclear model of the atom. Let's check what happened before this experiment. Before Rutherford's experiment, the prevailing atomic model was the Thomson plum pudding model, which proposed that the atom was a diffuse cloud of positive charge with negatively charged electrons embedded within it, like plums in a pudding. If you want to learn more about plum pudding model, click here. Let's see the setup for the experiment. A radioactive source emitting alpha particles helium nuclei was used. A very thin sheet of gold foil, only a few atoms thick, was placed in the path of the alpha particles. A fluorescent screen was placed around the gold foil to detect the scattered alpha particles. Now, let's check the experiment. Alpha particles were directed at the thin gold foil. As alpha particles struck the foil, most passed through with little or no deflection, while some were deflected at small angles, and a very few were deflected at very large angles, even backward. Let's see the results of the experiment. The majority of the alpha particles passed through the foil with little to no deflection, suggesting that atoms are mostly empty space. Some alpha particles were deflected by small angles, indicating the presence of a positive charge within the atom that repelled the positively charged alpha particles. A small number of alpha particles were deflected at very large angles, even nearly directly back toward the source. This was the most surprising result and could not be explained by the plum pudding model. What did Rutherford conclude after the experiment's result? Rutherford proposed a new model of the atom based on these observations. The atom contains a small, dense, positively charged nucleus at its center, where most of the atom's mass is concentrated. Electrons orbit this nucleus, occupying the remaining space of the atom, which is mostly empty. This experiment disproved the Thomson model and led to the acceptance of the nuclear model. That's it for today's video. Until next time, stay safe and keep experimenting.